Let us start with the examples of linear inequalities. As in the previous video, we discussed that the linear inequalities will always show you or give you the points which will be forming half plane. So linear inequalities will be forming half plane. Okay, so we have this 2x minus 3y less than or equal to 6. In that, if I divide by 6 directly, what I get is x by 3 minus y by 2 less than or equal to 1. Here the signs won't change, and what I'm getting is y-intercept is negative, x-intercept is positive. So in this I get a as 3 comma 0 and I get b as 0 comma minus 2. A is 3 comma 0, b is 0 comma minus 2. That is the point, because I can treat this equation as the x by 3 plus y by minus 2 less than or equal to 1. In this case, x by 3 plus y by minus 2 less than or equal to 1. In this, we have to include the points on the straight line. That's why I have 2x minus 3y equal to 6. So that is the equation of the straight line. The points on this straight line will satisfy the equation. We want equal to 6, but with that also we want less than 6. So we take a test point. As I said in the previous video, there is no need of taking random points. You take one test point. The test point is origin 0 comma 0, and put 0 comma 0 in the inequality. When you put 0 comma 0 in the inequality, you get 0 less than 6, right? Is true. So when you're checking 2x minus 3y for 0 comma 0, you're going to get 2x minus 3y as 0, and then 0 is less than 6, right? So if origin satisfies the inequality, you simply have to now shade the region containing the origin, and we say the solution is the half plane containing origin. The solution is origin side. Because if one point will satisfy the inequality, all the points in this region will satisfy the same inequality. We can check with the different values. Let us take minus 2 comma 1. You put minus 2 comma 1 and you get minus 4 minus 3 minus 4 minus 3 is minus 7. You put minus 2 comma 1 in the inequality, we get minus 4 minus 3, which is minus 7. Minus 7 less than 6 is true. Okay, anywhere around you can take a point. You can take a point here, 3 comma 1. It is not needed in solution. Only origin is sufficient to identify the region. It is not needed, but still I'm verifying with 3 comma 1. So when I put 3 comma 1, I get 6 minus 3. 6 minus 3 is 3 less than 6. So all the points here, infinite, all of them will satisfy 2x minus 3y less than 6. All the points here will satisfy 2x minus 3y equal to 6. All the points here will satisfy 2x minus 3y greater than 6, which we don't need. So I want this half plane which is containing the origin. I want the half plane with origin on the origin side. So this time the solution is origin side. This time the solution is origin side. Okay. The next example which I am going to cover is 2x minus 3y plus 6 less than 0. So 2x minus 3y is less than minus 6. Okay. And then when you divide by minus 6, you get x by minus 3 plus y by 2. But the sign will change. Because you are dividing by minus 6, negative number, the sign will change. Here you are dividing by 6, the positive number signs won't change. Inequality sign will change here because you are dividing by a negative number, that is minus 6. So you get x by minus 3 plus y by 2 greater than 1. So this is a little different question than the first one. In first, the x-intercept was positive, y-intercept was negative. In this, the x-intercept is negative and the y-intercept is positive. And then now, if you are going to plot the inequality, or you are going to show the point satisfying the inequality, you will get a half plane. Which side? Origin side or non-origin side? We have to find out. But before that, what I have to do is I have to make a dotted line here. Why I have to make a dotted line? Because in this there is no equal to sign. So 2x minus 3y plus 6 equal to 0 will not be included in the solution. The straight line will not be included in the solution. The point satisfying this equation will not be the part of the solution, and that's why it is dotted line. It is open half plane. In this it will be closed half plane. And what we are going to do is we are going to use the test point as origin. We are going to use the test point as origin. When I take origin and I put it in the inequality, whichever inequality, if you put it in the first one, before simplification, if you put 0 and 0 here, you get 6 less than 0. 6 less than 0 is false. Origin does not satisfy the inequality. So any point around origin will not satisfy the inequality. You can put this in the simplified form also. If you put x as 0, y as 0, you get 0 greater than 1, false. If you put it here, you get 6 less than 0, which is false. 6 is not less than 0, 6 is not negative. If you put 0, 0 here in this, you get 0 greater than 1. 0 greater than 1 is also false. 0 is not greater than 1. 1 is not less than 0. So you are not going to get origin satisfying this inequality. Not over here also, not in the simplified form, obviously not satisfying the inequality. So the points around 0, 0 will also not satisfy this inequality. So the points which are on the other side of the origin, the points here, you can check any random point and put it in the inequality. You'll be finding that the points on this side of the line will only satisfy the inequality. You can check any point from this side and put it in the inequality, it will satisfy. So this is the region which will be my solution for the inequality 2x minus 3y plus 6 less than 0. It is open half plane. It is non-origin side. The one here on this question is origin side, and the one here is on the non-origin side. So the one here is origin side, the one here satisfies the origin side, the one here is the half plane non-origin side, because in this half plane origin is not present, in this half plane origin is present. So the solution to this inequality is half plane containing origin. The solution to this inequality is half plane not containing the origin. It is half plane not containing the origin. Therefore, non-origin side, origin side. Non-origin side, origin side, open half plane, close half plane not containing the origin. Origin does not satisfy the inequality. Therefore, any point here will not satisfy the inequality. Okay, so we'll always shade the points which will satisfy the inequality. In this case it is non-origin side, in this case it is origin side. Okay, so origin as a test point will be very good, very easy for us. Now the problem with the next set of questions is you can't use origin as a test point because origin will be lying itself on the straight line. Origin will be lying on the straight line. So let us take an example, 2x plus y greater than or equal to 0. In this, the equation will be 2x plus y equal to 0, y is minus 2x, okay, y is minus 2x. Now if I'm going to plot this straight line, it is going to pass through origin. One point is definitely 0 comma 0, which I can make out because of the absence of the constant here. So origin will satisfy the equation, right? Origin will satisfy the equation. There is no constant. Now y is minus 2x. We want one more point. We want one more point. One more point. We can take it as minus 1. We can put minus 1. Then the output which we are going to get is 2. So we are going to get minus 1 comma 2. So this is the straight line. Which is 2x plus y equal to 0. Now origin can't be taken as a test point because origin itself lies on the straight line. So in this case, yes, you will have to use something other than origin. I would recommend something other than origin means you take a point on x-axis or you take a point on y-axis, right? That will be better. You can take a point on x-axis or you can take a point on y-axis. That would be easy to evaluate. So if I take 1 comma 0 and put it here, I get 2 greater than 0. 2 greater than 0 is true, satisfies. 0 comma 2 satisfies. If you take minus 2 comma 0 and put, if you take minus 2 comma 0 and find out 2x plus y, what you're going to get is minus 4. Minus 4 is less than 0. If you take this, what you get is 2x plus y equal to 2, which is greater than 0. So this side the points will be satisfying 2x plus y greater than 0. This side the points will be satisfying 2x plus y less than 0. The points on the straight line will be obviously satisfying 2x plus y equal to 0. What I want is greater than or equal to 0. The points on this half plane. Points on this half plane, points on this half plane will satisfy the inequation 2x plus y greater than 0. So we have to include the line and greater than 0. Okay. Next, we'll have to shade the region. We'll have to mark the points. We'll have to get the points satisfying x minus 2y less than 0. So what is the corresponding equation? X minus 2y equal to 0. What is the corresponding equation? Y is equals to x by 2. So y equal to x by 2. In this, the point again is origin. We have 0 comma 0. We have 2. X coordinate as 2. So we are going to get y coordinate as 1. So we have point 2 comma 1. So we have a straight line which is passing through origin, It is y equal to x by 2, which is x minus 2y equal to 0. Y equal to x by 2, which is x minus 2y equal to 0. So we have equation again representing straight line passing through origin. In this also there is going to be a problem. We can't take origin as a test point, so we'll take 2 comma 0, we'll take 0 comma 1 as test points. The points on x-axis, the points on y-axis not lying on the line as test points. And here the straight line should be dotted because straight line is not to be included in the solution. Open half plane, as we have discussed in many of the sums previously also, open half plane, straight line is not to be included in the solution. Let us take 2 comma 0 and put it in x minus 2y, x minus 2y, 2 minus 0 equal to 2 greater than 0. So this side is x minus 2y greater than 0. If I put x minus 2y, if I say 0 minus 2 is minus 2 less than 0. So any point here will satisfy x minus 2y less than 0. Any point here like 2 comma 0, there are infinite points here. Any point here will satisfy x minus 2y greater than 0. So any point here will satisfy x minus 2y. On this side will satisfy x minus 2y greater than 0. Any point on the straight line will satisfy x minus 2y equal to 0. Any point here will satisfy x minus 2y less than 0. That is what I want. So half plane is this. In this I can't say origin side, I can't say non-origin side. Okay, so this is both the examples which will be having straight lines passing through origin. Both the examples have straight line passing through origin. One is closed half plane, the other is open half plane. In this also I'm taking test point not as origin but as points on x-axis or on y-axis. You can take the points on x-axis or on y-axis. One point is enough to find out. If you take 0 comma 1, you will say yes, it satisfies. So any point around 0 comma 1 on this side of the straight line will definitely satisfy the inequality. You can shade the entire region satisfying the inequality. So the points here will satisfy x minus 2y less than 0. The points here will satisfy x minus 2y greater than 0. The points on the straight line will satisfy x minus 2y equal to 0. Okay, so that is how we are going to solve inequations. This is how we are going to mark the half planes.